aiming for you.
For my hand to cripple me from playing.
Man, so your item level's 560 something,
Like 568 maybe.
and you're 98.
Yeah. It would be better if I keep getting. Yeah.
No, it's killing me.
I'd be 100 if the servers weren't down or if I didn't have 3 clicks yesterday.
Well,
Yeah, listen to that video. That's what it is.
at level 90, I had a higher item level than he has now, so I got that. Like 568 or something like that. I guess there's evidence that gear didn't make any difference in leveling speed.
I mean, I'm guessing the people that like did it super fast by like 12 yesterday probably had like the highest.
Just blew stuff up.
Yeah, and then I think they did everything as a group. It was all that same good.
Yeah.
I'm still fighting pandas.
What?
I'm still fighting pandas.
When was the last time you were in the game?
A month ago.
No. Yeah. All right. So, this is our code, right? Oh no, this isn't. Thought that looked funny.
Vote chain.
Yeah, vote chain. All right, I want to document a couple of things here. So we were looking at our outs and our ins last time, correct? And we came to some conclusion. So right now we are reading in from the URL with the transactions from my account, getting our JSON object, getting the array of transactions. From that array, we're grabbing the final transactions out variable. That's what this guy ultimately becomes. And then we're going through and we're spitting out the outs. And we're just getting bucket 0, which is the address, if I remember correctly. Oh, no, we spit out the entire thing at the end. So for that very last transaction, here's the inputs. And the very first thing in that guy was, actually we're getting number 1 right now. We switch back between 0 and 1. I just want to document what inputs and outputs are. So when we write this, it makes sense. Okay, so there's that address. Is that our address? S9QS? Yeah, that's our address. So that was transaction number 1 from our transaction here. I think, was it the one down here? So this is bucket 1. Or is that? No, it was this one. We were the sender. So we sent 1.1 Bitcoins out someplace. Our 2 was to this guy. So I'm actually just going to click on this transaction and let's look at it. So 1.109 Bitcoins. Were you able to look at the actual? That's who we sent it to. And here's all the transactions associated with that address. Okay, so for in the outs for this guy, we should see a address of SUPR. Run this again. Okay, yep, here's our SUPR. So outs seems to be recipients who received, right? I just want to start document this a little bit. So this is BlockChain.info data API. outs seems to be recipients of their transaction. I think it's inputs is the sender of the transaction. Okay, let's confirm that. So for transaction 1, bucket 1, that's this guy right here. There should be 1.1 total Bitcoins that we are sending. So the outs should be the person we're sending it to. The input should be us. That should be our address. Okay, so the out should be SUPR, in should be our address. Here's the code. This is out. Here's the SUPR that we sent it out to. Is there anything else in there? Nope, that's the one recipient for that transaction. And then the inputs should have our address. We were the one who sent it. Here's the transaction index. We also have previous outs. That's the transaction right beforehand. That's on an individual transaction basis, previous outs. All right, so this is an example of a transaction where we sent the money, where we are in the inputs, and the outputs are who we sent it to. We're going to be monitoring a wallet that's going to have an address associated with it, and we're going to be interested in our address being the one we're monitoring inside the outputs. Okay, so if we look at transaction 0, this was where we received something. So we should be in the outputs. We should be in the outs of this guy, and the ins should be 4HQ, who sent it to us. So we're going to check that real quick. Instead of getting bucket 1, we'll get bucket 0, which should be that transaction. Okay, so we should be in the outs. And we're somewhere in the outs. Just before I go too much farther there, so I don't have to scroll tons back. The in should be the person who sent it. So this is the dude who sent it, the 64HQ. Then we have a big long hash, and then it should show previous. Oh, it only shows previous outs for us. Yeah, that's fine. So that's the dude who sent it, which is address 64HQ. Here's the 64HQ. That's who sent it to us. If we click on that, we're going to see all the places that he has sent money. So that's this list of recipients of that. So there's a whole bunch of guys there, of which we are one of them. Okay? This is actually kind of an interesting thing. This is certainly a pool, right? Unless it's just coincidentally that it's 25 Bitcoins. It's 24.6 something because they took the pool probably has fees. But so this seems like it's a pool payout. So this is a number of people that were in that pool. Isn't that what it looks like? So outs is an array that has a size. So for that bucket, if we here's that transaction. That transaction is a JSON object, which is going to have and out. So we can say JSON array, the recipients, is equal to JSON array version of transaction 0 dot get, and it's called out. Just run this real quick. So make sure I have the variable name right. Yeah, it's called out, which is going to be an array. And then we should be able to print out number of recipients is recipients dot size, number of elements in that JSON array. So 301. So there was 301 active miners for that particular block that contributed to. Well, actually, this is going to be an interesting little quick discussion about pools. So that's 301 people that the pool paid Bitcoins to. Does that mean there was only 301 people contributing on the pool? Does anybody know why?
The amount of distributions based off of the workload that one is done.
Okay, but let's say there's 1,000 people all participating with this pool. Okay, so we're all participating on this particular block, and we get our reward. Do all 1,000 people get paid out something?
All those who mine something.
Okay, well let's say all 1,000 mined.
No, but something like some of them have a great power of mining. Some
Okay.
of them are mining just two.
Okay, so some of them have a really weak piece of equipment. So they were small participants in it, but does that mean they get shut out completely? Don't they get paid a little bit too? I mean, they get paid relative to the amount of work they contributed, but don't they get their little cut? Out of curiosity, how many of you have, I mean, I know we've talked about it a bunch in here, but how many of you have ever actually gone and tried to mine on a pool? Got one person, I know Abe has, just those two people. Okay. So an interesting thing you run into, and this is actually a money-making thing with pools. Most pools have a minimum balance that you have to have before they will actually externally transfer it to an account. So for instance, let's say it's 0.1 Bitcoin. So let's say they won't send you your money until you have 0.1 Bitcoin. That's if you want to request an external transfer. Otherwise, it's like an internal wallet, right? It's sort of kind of like an internal wallet. You can't spend from it, so it doesn't work like a wallet, but it's kind of your account balance. Okay, like if you have store credit. Okay, so if you have store credit at Target and you don't use the store credit, it's still there. So these pools work that way. So my guess is there was far more than 301 people who were participating in the pool for that particular block. But what ended up happening is only 301 either A, had their threshold set up to actually pay out as opposed to just keeping their balance in the pool, or only 301 met that minimum threshold for the payout. Okay, if everybody just has it set up where, yeah, just pay me as often as you can, as often as I can get real Bitcoin out of the pool, I want that. Which I don't see a great reason not to do that, right? You know, you want the pool to have as little of your Bitcoin as possible. So my guess is that's what happened. But once you get enough mining power, so for example, I only do transfers out of my pools manually. Otherwise I'd be having, probably, I don't even know how many 10-minute segments are in a 24 hours times 60 minutes times 10. That's not right, is it? So 24
times 6.
times 6. No.
Yeah,
24 times 60 is the number of total minutes in a day, divided by 10 is the number of 10-minute.
Which is the same.
Same thing. You're okay. I get you. So that means there's 144 segments in a day if every block takes 10 minutes. Okay. So my guess is that I would meet the minimum threshold at every payout. So I would have 144 transactions a day. I mean, I wouldn't be getting tons and tons of Bitcoin, but I probably get 0.1 or 0.2 Bitcoin per 10 minutes from my mining power, which isn't like the professional level, but it's probably pretty heavy. I have like 2.5 or 2.7 terahashes of power.
So do you just go with one company, or do you go with a couple? Because if your one company wins and the other company wins the other half of the time, you could kind of win both times, I guess.
I don't. I only mine with one, just because so much of my mining is cloud-based mining. Having said that, there's probably some math you can do to find out if there's a statistical advantage to what you're saying. I guess my feeling is that over time it all kind of balances out. If the pool you're working with wins 40% of the time, and another pool you're working with wins 20% of the time, it's because it probably has half the mining power, which means that you have twice the contribution to it. So over time it should balance out, but you might have streaks of good and bad luck. So my guess is I used to mine on a pool called BTC Guild. And my guess is if I log in there, I probably have some Bitcoin in my account. That was when I first got into it. That didn't meet the threshold. So I have an amount of Bitcoin in that account. So let's say the threshold is 0.1. Maybe I have 0.09. So say that's the case. I can never get that 0.09 because it never hits their threshold. So they own that. They basically, it's theirs. They never have to pay me. So I can go on there and try to get to the perfect number, right? Just mine long enough to win once to get to 0.1, and then take out the 0.1. I'm at 0. But there's actually some fractions of pennies in there, so it's kind of like what the movie Office Space.
Yeah.
Where the guy had the wrong. If you've seen the movie, there was a couple of programmers, and one of the guys they were in a financial company, and they were skimming off of bank transactions. And they were taking fractions of a cent from every transaction, which over time added up. And they redirected it to a bank account that they had set up. Well, the guy put the decimal point in the wrong place. They were taking more than fractions of a penny. So all of a sudden this account was just huge. And, you start taking 1/1,000,000th of a penny, nobody notices. You start taking $4 from every transaction, people start noticing. All right. So in any case, that's the number of transactions that particular guy paid out to. And if we go out here, does this actually give me the sum? It doesn't actually tell me. So the number of people, so since it paid out 24.6 total Bitcoins, part of that might have been fees, or there was 0.4, 0.37 Bitcoins that went to people's accounts internally that weren't paid out. Something like that. And if you see, most of these are 0.01, which is kind of the minimal for most places. I'm guessing this guy was a pretty strong contributor. Yeah, so this guy got, out of that award, he got 19.9 of the 25 Bitcoins.
That might be.
You?
Do you think that would be
The pool itself?
the pool itself? It's keeping hold of everybody else's tiny amount?
I don't think so. I'm thinking this is the pool itself. Because the pool would get the reward. They would get the 25 new Bitcoins, and then they would distribute it out externally.
You think they might have
Like they're one of the miners. Like the pool itself has their own thing set up.
Yeah.
So they treat themselves as one of the customers as well.
Yeah.
Possibly. Just out of curiosity.
Or those could be all the unused hashes, right?
Say this again.
Could that be all the unused hashes?
All the unused hashes.
Or that's the mining power that the company would use and the group would use. And that's
Oh, so like if it's CEX.
Yeah.
So any of the hashes that nobody currently owns, that's their equipment that they're using? Possibly. This was actually, I think, before. Well, actually, this is a recent one. So this would be CEX. So this guy made $9,500 for that 10-minute segment. Pretty decent. Okay, but this was the address.
Stuff to make that much though.
What's this?
Wonder how much he spent on this stuff.
More than 10,000.
Yeah.
And then another guy won 7.
So this was the address. So it went to this account and then he transferred it somewhere else. But the idea is, so he sent it out to, oh, he did send it back out to other people. So you actually might be onto something. You know, he took that 19 Bitcoins and he sent it out to a whole bunch of people. So maybe it's a pool within a pool. That actually could be true. That one of the members of this pool, so let's just say this was CEX, because I think it was a recent transaction. So CEX has within it a user, and that user actually has their own pool. So the pool is also a user. Make sense? So using CEX might be BTC Guild. So that user got their payout, and then they distribute it to the people in their pool. So biggest recipient there was the 7. It looks like it might be. It looks like it might be. So this guy maybe had also a mini pool. How far does the rabbit hole go? Oh my gosh.
There's another larger.
They must have pools within pools within pools.
That's what it is. Because, you know, you look at the payouts, these are all like pool payouts.
Except that there's one.
There's one that was bigger, right?
Yeah.
So here was the big contributor for this pool. 1.3. Was he running a pool? Well, maybe.
I mean, it's kind of, but those are off numbers, so.
Well, this guy got 1 Bitcoin, so this is this pool of of like, you know, cafeteria friends at Concordia.
Yeah. Basically, it's a pool of poolers.
Actually, sort of kind of this guy paid out. I would have never guessed it worked that way. Don't tell me these guys are individual. No. Yeah, there's something's not right here.
We stumbled upon someone working the system. You found my Bitcoin.
I mean, how far down do we have to go till it's a single transaction? Here we go.
There we go.
It didn't become a single person until we were like 9 steps in.
That's how the crime ring goes.
Well, actually, hold on. We can explain this in some ways. If somebody has multiple, and I'm not sure exactly how the pools necessarily work from this perspective, but so it's an interesting question. So, for example, in my office, I have 2 machines that are mining. Then I have a bunch of cloud computing that's also mining. So I have 3 devices that are mining. When I get paid out, does it pay me, or does it pay once for one device for its contribution, once for another device for its contribution, and once for another device because each of it's for its contribution? Because each of my devices have a unique name in my account for mining. One's called Worker 1, one's called Worker 2, one's called Worker 3. So if each of my pieces of equipment have their own unique name, then you get a payout per piece of equipment. So one person would actually be 3 in my kind of small amateur operation thing going. Well, if you have another guy who has a whole bunch of machines that each have workers, so like, you know, some of these server farms that these places use, especially the older ones, have just walls of USB plugs, where there's just a whole bunch of these USB mining devices. Each one is, you know, a very insignificant piece of equipment in and of itself. But when they all work together, they become much more powerful. That makes sense? So there's a possibility there's something like that going on. But at the very least, it seems like there's at least several layers of pools within pools, which is kind of interesting, I think. But maybe the fun thing here was we were actually just reading from the blockchain. That's what we were walking through that transaction. All right, so back to what we were doing here. We saw that in our documentation, the outs are all the people that address sent to as a portion of this transaction. Is that a true statement? So if we go back into my list of, oh, it's good security. It times you out like after about 5 seconds. So here's my transactions. Here's me receiving stuff. So in this case, I would be in the inputs, right? Here's the address that it was sent from. Well, actually, this is me receiving something. So this is who sent it to me. This would be in the inputs. We marked that, right? We said inputs is sender of the transaction. So that's our inputs. And then the outs would be all of these guys. Okay, so this particular address sent out 2 separate transactions in this block. They had one transaction that was to all of these individual people. Okay, so that was, what did we say, 301? There was 301 transactions there, totaling 24.6 Bitcoins. I was a little piece of that, so I'm somewhere in here in this list. And then they had one additional transaction where they sent, actually this was 158. This was at 301.92/2014. Yeah, so this isn't per block. This must be reading from the blockchain forever. This is parsing the blockchain. So this particular address sent out a bunch of coins and earlier received some coins. So at 1:58, so let's just say this is either AM. At 2 a.m., this address received 24.6 Bitcoins as a reward, whatever it is, whoever this guy is. Probably a pool, received 24.6 Bitcoins. A couple hours later, 3:01, or was it 1 hour later, whatever it is. Yeah, 1 hour later. He then redistributed those 24 Bitcoins to all of these individual addresses. That make sense? So the transaction we're currently looking at is this top level guy here. I believe it shows just that, not all of them. And we'll confirm that here in a second. So the inputs for this transaction should just be this address, the 64HQ.
So if that's a pool, why don't they have other transactions received? Like
They might use a different wallet address on each individual block. Yeah, it's pretty common because, like, for instance, I'll show you here in a second. Let me just make sure the inputs are what 64HQ, that was the sender, okay? And then the receivers are going to be all these dudes, big long list, those 301 dudes. Now, as an example with what you were just asking, I can go into my wallet and I can say I want to receive money, and I can generate a brand new address for this particular, so it's associated with my wallet, but let's say that I'm sending you an invoice and I want to track whether that invoice has been paid. I can generate an address just for that transaction. So I can label this for whatever I want to name a transaction, maybe invoice number 1302. And then I could say whether to make it public doesn't matter. I'm using it for my own internal accounting, and it will have an amount of money that's ever been sent to that particular account. But they're all housed under this one wallet. That makes sense? But even when we say that, we say it's all housed under this one wallet. This could very much be how we set this up for our voting. You know, we have a single, let's just assume we're using BlockChain.info for our, our wallet that's going to store our votes. Well, within one wallet, we can set up a individual address for each candidate. Vote for this candidate by sending coins to this wallet address. Send it to this wallet address for this candidate, so on and so forth. All those payments go into the pool that is this one wallet. But we can piece it out by looking at these individual addresses. Make sense? That's one way we can set it up. Okay. So, if we are looking at this from the end wallet perspective, and we want to see how many people paid the candidate 1 wallet address, we're going to say the candidate 1 wallet address is our wallet address, which is this guy. Okay, that top level guy. What we then want to do is, as we spin through here, so we're not interested in the keys at this level, well, let's keep printing them out just so we don't forget the names of the variables. So we're going to say, when we get here, let's look at the current transaction and see if we were the recipient of a payment. Then we'll figure out what that payment was. Okay? So we're going to do that by going through each of the recipients, so every single JSON object that's in the recipients, and that guy looks like this. Here's the recipients. The recipients is an array of recipients. We have a value that was sent, who it was sent to. Next one, value that was sent, who is it sent to? So the second one was sent to 5GF, and this is, I think, 0.01. We're looking at this one, right? Here's the 5GF, and here's the 0.01. So they gave us the number in Satoshis, but for Bitcoins, it's 0.01 Bitcoins that was delivered. Right? So each element in that array is a JSON object. And that JSON object has a bunch of crap in it, and the one we're interested in is the address, and if the address matches, the value that was sent. Those two pieces of information. Okay? So let's print those out. So for oh, did we decide we couldn't do this last time?
I think you had to. You got it to work. I think you had to. I think it returned an object. So you need.
Well, but switching this here. Oh, doesn't matter. Be a waste of time. So for int I is equal to 0, I is less than the recipients dot size I plus plus. So we'll go through all of those recipients. And for right now, let's just print out who was the recipient and how much was sent. All right, so we're going to have a JSON object. Let me define that outside of this, actually. JSON object, cur recipient. We'll say cur recipient is equal to the JSON object version of the recipients dot get I. So for each JSON object in the list of recipients, we'll get that object stored inside of cur recipient. Then we want to print out the address and the value that they got, just to prove that we got it. So we'll say system.out.println cur recipient. I don't like that word. Dot get, and it was address concatenated with, let's just do a little arrow looking thing, cur recipient dot get value, which should give it to us in Satoshi, which is fine. All right, so we do all this rigmarole. We're still printing out the names of our variables so we don't forget them up here. Down here, we'll get our array of recipients, spin through them. For each of those recipients, we'll print out their address, followed by a little arrow-looking thing, and the value that was sent to that address. So it should give us something that very much looks like this kind of thing. List value, except the value we'll put out is in Satoshis. Okay, well, I can tell you right off the bat, it's ADDR, not address. That's why we got a bunch of nulls over here. You know, we put in the wrong variable name. I was testing you and you failed. Okay, ADDR. Now we'll have actual addresses there. Okay, so there's our addresses for every payment that was made. And here's the value in Satoshi. If we want to get that value in Bitcoin, we need to multiply it by our value of Satoshi in 1 Bitcoin. So this would be integer.parseInt this value. And we're going to take 0.23456. I think there's only 7. I think it's 7 zeros and a 1. So that times and this guy is going to come out as an object. We'll just cast it to a string. I'm missing 1 parenthesis. Okay. So we're going to multiply that Satoshi value, the integer version of that Satoshi value, by what 1 Satoshi is in Bitcoin. And if we want, we can put a little BTC at the end, labeling it as that many Bitcoin. Retro. Oh, that's interesting. That guy is not a string. It's a long. So actually, our get method for cur recipient is a lot smarter than we expected it to be. It doesn't come out as a string. It comes out as a long value. So this guy is a long. We're probably still going to have to do this. To get it back to a primitive type. So we were just told that this guy is actually coming out as an object of type long, So we'll cast it to an object of type long, and then ask that object to give us this long primitive value, which we can then multiply by our primitive. You think? So that. And so that one closes. Well, what I really don't need is, oh, I want this to be the one value. Okay. Testing you. Actually, it's true. I'm actually surprised a little bit. All right, that look right? So I did guess at the right number of zeros, 7 zeros. It's 0.701 is 1 Satoshi. So there's all of our transactions in Bitcoin. And if we added all those up, we should get out to that. Oh man, look at this dude. Let's get precise with this. Okay. All right. Now, we're specifically looking for our address in here, right? So right now, we're getting all the individual addresses. So let's just break this down into a couple of variables, and we're eventually going to pull this into an object, but right now we've been experimenting with the data to make sure we understand what the data looks like. So let's take an NS string, wrong language. Let's take a string, what was I talking about? Cur address, and let's take a double cur BTC. And we'll set cur address equal to.
I think that's the first time I've seen you mix up languages.
Really? No, it happens kind of often.
I can't remember any of it.
Really? All right. So are you impressed or unimpressed?
I'm impressed that it took this long.
Score.
So I'm either impressed that you haven't done it yet, or I'm impressed that I never noticed it.
Oh. Well, actually, so maybe this is an interesting related question. So we have a couple of students in here where English isn't your first language, right? Do you guys ever fall into situations where you accidentally say something in your native language rather than English? Like, accidentally. Yeah. See? All the time?
Yeah.
It's like common? Because you think in your language, right?
I tried.
Okay.
In English, but it's hard.
Okay, so you're in that transition period, you know, because like, you know, I only know, I mean, I took a Spanish class, but I only know English. I took like 2 Spanish classes, so I think in English, so I don't run into that problem. But if you're thinking in Portuguese, and all of a sudden you start spitting words out. I had a friend in grad school, was a Japanese guy, and him and his brother, when he spoke English to me, but you know, obviously his Japanese was his first language. When his brother was in town, who only spoke Japanese, we'd be out to eat, and him and his brother would be, you know, babbling in Japanese, and all of a sudden you just hear him randomly drop English words in there. You know, and I sat there and I felt like they were stealing from us. Like, wait a minute, that's ours. That's it's always like company names and stuff like that. All right. All right, so cur address is going to be the current address that came out of there. And then cur BTC, which is going to be a double, is going to be equal to what I did there with that guy. Missing one closing.
You have an extra one.
Yeah, I actually don't even think we need this one.
I think on the line below you have an extra one on the end.
But we don't need this one either. So here's the long, get its long value, multiply it by this. Okay, then we're going to say cur address. And then we have an extra one here, as you pointed out. All right, so this should print out the same crap for right now. I just put it into some variables. All right, same stuff. All right, now we're only interested in whether or not we had a transaction. Somebody sent us some Bitcoin. So quickly, let me steal my wallet address again.
Show the public API.
Huh?
Should show private API.
His private key.
Yeah, the private key.
It doesn't matter. It's disabled. Yeah, you can use it all you want. I only enabled it during class and disabled it immediately following class because I don't trust you.
Good reason.
Wait, you enabled it during class and disabled it during. Oh, you just use it during class then.
That's true. No, I mean when we were working on it. I don't just randomly walk into class now and just turn it on for no good reason. But yeah, during the classes where we were working with CEX, I was vulnerable. I think that's what you're trying to say.
Yeah.
I was definitely vulnerable.
Oh, yeah, true.
Okay, so what we're going to say here is we're only going to print this stuff out if cur address dot equals our address, just for right now. Proving that somewhere in that list is us. There we go. So somewhere in that list of 301 things was them sending some coins to us. All right. So next class we'll come back. We're going to clean some of this up now that we know what these variables mean, and we're going to start counting these as votes. All right. I will see everybody on Monday.